Graphs of linear functions. We're going to look at first two identifiers that we can use when we're looking at linear functions, and that's your vertical and horizontal intercepts. So what we're going to do is first figure out how to find them algebraically, and then we're going to use them in order to graph a line. With a vertical intercept, you're looking at the y-intercept, so that means you want to set x equal to 0 and solve for y. Now, the thing that catches students is the result of this is going to be an ordered pair of 0, a number. And so just be careful when you're entering those answers. It is an ordered pair. The other type of intercept is the horizontal intercept, which is your x-intercept. So this means now you're going to set your y equal to 0 and solve for x. So again, that result is going to be an ordered pair of an x value, 0, close parentheses. So let's execute that in this next example, and it says graph the line and find the intercepts. Now, if you feel more comfortable, you can say that this is y equal to -3 plus 1/2 x. And you can just look at it with your y's instead of your f of x's. So we're going to split this into two. I want to find my y-intercept first. So when you're looking for your y-intercept, you're going to set your x equal to 0. So you're zeroing out the letter you're not looking for. So your y-intercept is going to be y equal to -3 plus 1/2 times 0. Anything times 0 just zeros it out. So I get y to be -3. And then always write that intercept as an ordered pair. So it's 0, -3. We'll use that in just a minute. Next, we're going to find our x-intercept. So that means when you're looking for your x-intercept, you're going to set your y equal to 0 and solve. So that gives you 0 equal to -3 plus 1/2 x. A little bit more steps in order to get that x by itself. So we want to isolate this x. So I'm going to add 3 to both sides. That gives me 3 equal to 1/2 x. And then divide by 1/2. Just use your on-screen calculator. 3 divided by 1/2 is like multiplying by 2, so it gives you 6. So the x-intercept is 6, 0. Now, the whole reason you want to find intercepts, there's our application process to this, but in this example, I just want to use it to graph. So I'm going to come over here to my graph. I'm going to make a dot at 0, -3. So I can place it here, and then I'm going to make a dot at 6, 0. So 1, 2, 3, 4, 5, 6. And then I'm able to connect those two together. And so with this situation, we're just looking at the two intercepts. Again, there's a lot of application that we can see with the intercepts, but we're just kind of starting with the foundational skills. So we have our x and y intercepts. What I want to jump into is your horizontal and vertical lines, two very special linear lines, linear functions. Your horizontal line is going to be when your slope equals 0. And so that means if we're thinking about this in terms of y equals mx plus b, this is y is equal to 0x plus b. So that means it's just y equal to b. So all of the equations of your horizontal lines are going to be at y equal to b. Say, for example, we said, let's let y equal to 2. That means here's 2 on your y-axis, and then we could just draw a line through that value that's horizontal. You'll notice that the equation was y equals 2, and it ran perpendicular or opposite to your y-axis. Now, students normally are okay with a horizontal line because you have values that you can plug in. But what happens with your vertical line is, reminder, the slope of a vertical line, this slope is undefined. So we can't take that path and say, okay, well, let me write y equals undefined times x. Like, that's silly. So we don't want to do that. When we're working with this one, we're going to say, okay, the slope is undefined. This is x equal to a number. So you can see this is y equal to a number. This is x equal to a number. So if I had x equal to, say, 3, then I would go 1, 2, 3. And then I could draw my vertical line through that x value. And so just be careful with your horizontal and vertical lines. They do have a really quick process on how to get them, but you want to make sure you have them distinguish which one is which. Now, when we start to compare different lines, I already kind of alluded to this in that last one, we start to look at parallel and perpendicular lines. So let's just kind of outline what that means and how that can work for us. Parallel lines mean that the lines never intersect. And if those lines never intersect, that means they have the same slope. So that's the algebra sense that we're going to grab from that. If they are the same slope, in the next example, well, you can go ahead and do kind of generically. That means if I had the slope of 7 on my first line and I want them to be parallel, that means my second line would also have a slope of 7. So looking at this example, it says find a line parallel to f of x equal to 6 plus 3x that passes through the point 3, 0. So in this situation, make sure that you use all the information that is given. It says find a line that is parallel. So mentally you should be thinking, okay, I need the same slope. So in the given line, what I want to do is I want to pull that slope out of there and say, okay, I want a slope to be 3 so that they will be parallel. And then we're going to use this point. Make sure you use all the information that is given. We have one single line of data. If we're not using that point, we're not on the right track. So since I have 3, 0, and that's an x, y value, I can use my point slope form. Y minus y1 equal to mx minus x1. And I can plug in all my values. So I have y minus 0 equal to 3x minus 3. So I'm going to distribute. That gives me y minus 0. I'm going to quit writing that because y minus 0 is just y, equal to 3x minus 9. So you can see 9 did not exist in that problem. So if I'm not careful, I may just shortcut this. That process did not take very long, but 2 things you did need to know. You need to know that they were the same slope and make sure you use all information that is given. Now, the reverse of a parallel line is the fact of perpendicular lines. So when we're looking at perpendicular lines, we say that these intersect at a 90-degree angle. And so if they perfectly intersect at a 90-degree angle, I don't want to take 2 lines and measure out that angle. So we're also going to use slopes with this. Then the slopes are opposite reciprocals of each other. And those are just big vocabulary words for meaning if I had, say, the slope of negative 4 over 3. The line that would be perpendicular, and that's a symbol for perpendicular, would mean you just take your slope and you flip it. So it gives me 3 over 4 and change the sign. So the slopes are opposite. One's negative, one's positive. Reciprocals, meaning I'm going to flip that around. So in this next example, you can see it says find a line perpendicular to f of x equal to 6 plus 3x that passes through the point. So same advice, make sure you use all the information that it's given. And let's kind of go through here and just pull out our key information. Find a line perpendicular. So that means I want opposite reciprocals to the given situation. So let's go ahead and figure out what that slope's going to be. If this slope is equal to 3, I need to flip it and change the sign. Now, sometimes that can be difficult. Well, not difficult. It might throw us off because that's just an integer of 3. If you don't have a fraction, you can just put it over 1. And so now when I create the slope that I'm needing to be perpendicular, that gives me 1 over 3. I just flipped it and then changed the sign. So this is going to be the slope that we're going to use for the problem. And again, don't forget we want it to pass it through this point. So that means with a point 3, 0, this is going to be my x1 and my y1. So we're going to do it just like we did in the previous example. I'm going to say y minus y1 equal to mx minus x1. Plug in the data I have, so that's y minus 0 equal to negative 1/3 x minus 3. I'm going to distribute, so I get y minus 0 equal to negative 1/3 x plus negative 1/3 times negative 3 is a positive 1. Use your on-screen calculator to assist you with that. Y minus 0 just gives me y, so I get negative 1/3 x plus 1. So you can see the processes for both of these examples is exactly the same. It's just a matter of identifying what slope and information you have. Again, the fact that it's perpendicular, we're going to be using opposite reciprocals, and then also remember how to create an equation of line. And the last type of line we're going to look at is intersecting lines. When you're looking at intersecting lines, we have the fact that we can be parallel, never intersect. We have the fact that we can be perpendicular and perfectly intersect. But intersecting lines are just lines, that intersect at one point unless they are parallel of coinciding or they're the same line. So what we're saying with that definition is we're just looking at two lines crossing, and when they do cross, the takeaway from this is that they're going to cross at one point. So if I'm trying to find where two lines intersect, my answer is going to be some x comma y value because they're going to cross at one point. Now, the only situation where they don't intersect is parallel, or if they're coinciding, meaning you just have two lines drawn on top of each other. And so here's what we're going to look at with this situation. If we're looking at intersecting lines, the way that we're going to figure out where they intersect is we are going to set the two equations equal. And so I'm going to say h of t is equal to j of t. So that means I'm going to have 3t minus 4 equal to 5 minus t. And now I just have one variable, so I'm going to solve for this t in this situation. So I'll say, okay, let's add t over. You could have chosen another step. It's just the step I chose in this moment. So it gives me 4t minus 4 equal to 5. And again, I'm trying to solve for this t right here. So I'm going to add this 4 over. That gives me 4t equal to 9. Again, our main goal is getting this t by itself, so I'm going to divide both sides by 4. So it gives me t equal to 9 over 4. And we're not going to fret that we have a fraction. Our goal in this thing is an ordered pair. And so over here to the side, I have some ordered pair. That's my end game, what I'm trying to fill in. 9 over 4 is the first part. In order to figure out the second part, I'm just going to plug it into either of those situations. So whichever one makes life easier for you. So I'm going to say, what is j of 9/4? It looks a little bit easier situation, but it doesn't matter. 5 minus 9 over 4. I'm just going to use my handy dandy calculator on screen. It gives me 11 over 4. Now, the reason we would take the algebra approach to this, because if we look at these two lines, so let's see, we have -4, 1, 2, 3, 4. We're going to go up 3 and over 1. Just graphing these two lines for you. And then I'm going to take the other one, which is at 5, 1, 2, 3, 4, 5. And down 1 over 1. These are not crossing at a very nice point. It's like 2 and a 4th. And so what we would see is this wouldn't be one where we could just stare at a graph and get it, but our algebra skills are going to help us with this. So I hope this short lecture kind of helps you with all our different linear functions: horizontal, vertical, their intercepts, parallel, perpendicular, intersecting. Go and try the homework and then contact your instructor if you need assistance.